Hi, welcome to the Calculus 1 lecture series. We are starting unit number 1, and unit number 1 covers the fundamental about the derivatives. We talk about unit number 1 is the limits and the derivative. And this is our second lecture for the unit number 1. And since this lecture is kind of the long, so I'm going to break this lecture into 2 videos. So this video is the part 1 of the lecture number 2, how to find the limits of a function here. Okay, so and we're going to break into 2. So this is the part 1 for the lecture number 2. See here. All right, so now let's go to our lecture notes and see, what we're going to nurse here. All right, so the first, let's take a look the limits of the functions here. So what is the limits of the function? The first, let me show you the notations here. So this is what we represent the limit of the function. We said limit x approach to a, f of x is equal to what? Equal to else here. Okay, that means, as the x gets closer and closer to the number a, but then you don't have to equal to, right? But not equal to a. That means I'm just getting closer and closer, but then I'm not equal to a. I'm just getting infinite, it's very, very close. Then the corresponding, okay, so the corresponding f of x, right, so values get closer and closer to the number L here. All right, so let's basically, it's telling you here, I have the functions here, all right? So this is my function. So let's say here, this is my functions here. So this is my f of x here. And then I have, this is my a value, all right? And this is my a values here. And for example, this is my L values here, right? And then when the limits, what that means here? That means here, this is my, let's put it here, the color one here. So let's put it here. This is my, so this is my x value. So the x nears a, right? It's getting closer and closer to a here. Now I'm getting of values here. So this red value, we say f of x nears what? Nears the L. That's how do we define. And the notation we use is here, right? So it's limit x approach to a, and then the f of x will getting closer and closer to the L's here. Okay, so let's take a look here, right? So we said, all right, so in here, the first number here, we said when x getting closer and closer to 9, correct? So when the x get closer and closer to 9, what is this value going to get close to? This value going to get closer and closer to what? To 4, right? Okay, so the same way is here, right? So when x getting closer and closer to 4, now what is this value getting close to? So it's 2 times 4 is 8, right? So 8 plus 6 is 16, 14 here, right? So when the x is getting closer and closer to 4, then this value will getting closer and closer to 14. So that's why we say 14 is the limits here. All right, So now the next one's here, like for this example here, we say when the x getting closer and closer to 2, so what is this value going to be? So this one going to get closer and closer to 2 to the third. So we're getting closer to what? To the 8th here. Okay, so this one is very interesting. So they say I have a constant function, it's 7. Now when the x getting closer and closer to 3, is it going to affect my constant function? No. So what is the value of here? The value of here is 7, right? So think about it like this. If this is your constant functions here, right? So if this is the 7th, right? And then you have a values here. So this is 3, right? So this is 3. So now you have x here. So when the x is getting closer and closer, so doesn't matter because this is fixed function. So it's getting to what? To the 7th here. All right. Okay, so now let's take a look at the problem number 2 here. And the problem number 2 will, give us the idea of what we're going to define the bottom here. Okay, take a look at this graph here, right? So take this graph, let's say when the x is getting closer to -5. So -5 is here, right? So the -5 is here. Now when the x is getting closer and closer to -5, what is my function value going to close to? Going to close to 4. Correct? Okay, so now this one is very good questions here. So let's say here, it says here, when the x getting closer and closer to 2, right? But not equal to 2, right? So when the x getting closer and closer to 2, but not equal to 2, what is this value going to be? We're going to closer to what? Close to 3 here. All right. And now I'm going to skip the C and do D first. And we'll go back to the C and what are going to give us the remaining this definition. Okay, the x approach to 4. That means when the x here getting closer and closer to 4 here, right? So what is your value going to close to? The value going to close to 0. Okay, so now in these numbers here, part C here, let's take a look here. When x are getting closer and closer to 0, here, this is the zeros, right? So we said I'm getting closer and closer to 0. If I getting closer and closer to 0 from this side, what is my value going to getting closer and closer to? Close to 0 also. But if I'm getting closer and closer to 0 from this side, what is my function value going to be? Whoa, it's going to become infinities here. So for here, I cannot decide. I say, I don't know, when x approach to left, approach to right. Okay, so this one's here, I do not know, right? So do not exist because I cannot, one approach to here, another approach to here. So this is give us the definition about the limit. We have the left-hand side limit, we have the right-hand side limit. So what is the left-hand side limits here? So remember, right? So this is the A. So I want my x getting closer and closer to these numbers, right? Close to the A. So I have 2 directions to get to that, right? So what is left-hand side limit? This is what we say is the limit x approach to A. I use a negative sign. So that means it's a little bit smaller than A. So this side is here, we call this the A minus here. So that's what we call this left-hand side limits here, all right? And then we said approach to A from the left-hand side, and we say if this limit, let's say, is L1, see here. Now for the right-hand side, just like here, I approach from the right-hand side. So that means I use the notation a plus. That means all the values here is a little bit greater than a, right? So that's why I have a limit x approach to a to the positive sign, f of x equal to the L2 here, okay? So now when we say the limit exists, right? So in here, based on our definition, we say, what is the limit? Limit approach to a, f of x equal to L. So that means, okay, so now if I write this way, I say limit x approach to a, f of x equal to L exists. What's that mean? That means limit x approach to a from the left-hand side is equal to the L1 has to be equal to the limit x approach to a from the positive sign, the f of x, and then they're all equal to else here. So that's how do we define that a limiter exists here. If you look from the left-hand side, you look from the right-hand side, and they both will approach to us same limits here, right? As we defined here, so this is very important, right? So we said the limits here, right? So we say it's getting closer and closer to the number a, but not equal. All right, so this is very important. It's not equal. That is why for these examples here, right? So we say when the limit approach to 2, so that means I'm approach to from this side, approach to from this side, they go both going to give to very, very, very close to 3. But it's not equal to when the x equal to 2, when the x equal to 2, f of x2. So for these functions here, the f of 2 is what? Is 5, right? So, but it's not equal to the 2, right? So we're just getting closer and closer here. So this is super, super important, right? So how do we define the limit exists? That means your left-hand side limit has to be equal to the right-hand side limit. And they have to have the same numbers here. All right. So now let's take a look at these examples here. Okay, so I think after we do this example, we should get pretty good ideas about the limit approach to left, limit approach to, okay, to the right. Okay, so let's take a look at this ones here. Okay, so this one is approach to the -2 from the left-hand side. Here is a -2 from the left-hand side. That means I'm approaching to here, getting the like a boom, 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 boom. So what I'm approaching to, right? When I'm getting closer and closer to the -2 from the left-hand side, what is my value close to? Close to 1. All right? Okay, but now if I approach from the right-hand side, that means I'm going on the curve like from the right-hand side here, right? Okay, so what is my limit approach to? It's approach to 0. Correct? This is from the right-hand side. And because I approach to from the left-hand side, it's different than I approach to the from the right-hand side. So if I just say the limit x approach to -2, what is this one here? Is do not what? Exist. Because my left-hand side limit is not equal to the right-hand side limit. Okay, now let's take a look again, the other one. So this is the x to the 2 from the right-hand side. That means I'm approaching from the right-hand side, right? So I'm approaching from here. That means my function value is going to approach like this way. All right. So what is it going to approach to? Like you approach to this way. What are going to approach to? It's going to approach to what? Approach to 3s, right? Okay, and then now if I approach from the, this is what's that mean? That means from the left-hand side. That means from the left-hand side, I'm approaching to here. That means my function value is going to go down like this way, right? So what is approaching to? It's approaching to what? Approaching to 0s here, right? And because left-hand side limit is not equal to the right-hand side limit. So what I can say about the x approach to 2 here, is do not what? It's do not exist. You get that? Okay, so now let's take a look at the other ones here. So this is x approach to 0. What is this one's? From the left-hand side, right? From 0. So from the left-hand side, that means I'm approaching to from left-hand side. So that means that my function value going to like this. So what is approaching to? Is approaching to 1, right? Okay, so now I'm approaching to the 0 from the right-hand side. I'm going to this way. That means I'm approaching to the function go like this. So what is my limit approaching to? Is approaching to 1. Oh yeah, so I have a left-hand side limit equal to the right-hand side limit. So I know my limit to x approach to 0 is what exists. And what is the exist value here? Is 1 here. Okay. All right, so that's very good. So I think if you understand this graph, then you got a pretty good understanding about the limit approach from the left-hand side, right-hand side. It's basically the, what is your graph value will approach to, right? So sometimes you can just draw it and say, hey, do they approach to the same value? And they don't have to equal, right? All right, so now let's see here. So we say if the limit x approach to 2 does not exist, then we will say x approach to 2 from the right-hand side does not exist. What is this? Sometime, always, or never? This is what? Sometimes, right? Right, so sometimes your right-hand limit can exist, and but then the limit itself doesn't exist, like these two problems, right? So this one and this one here, the both you approach to the right-hand side, the limit exists, but the limit itself does not exist because the right-hand side is not equal to the left-hand side here. All right. All right, so that's pretty fun, right? Okay, let's take a look at the problem number 5 here. So I want to find the limit x approach to 2. Okay, x approach to 2. So now we know when we want to find the limit, I'm always need to go to find the right-hand side limit and the left-hand side limit, right? So I said the x approach to 2. Now let's do the left-hand side first. So you still remember, right? So what is this means? Left-hand side, that means it's always a little bit of what? It's a little bit less than 2. So which function I'm using is less than 2? Oh, here, right? So it's less than 2. I'm using this one here. So when the x is approach to 2, it's a little bit less than 2. So this will be what is the seventh, right, will be approach to seventh here. Now the same one here, let's see here, if x approach to 2 from the right-hand side, f of x here. Let's take a look at this one. That means this is right-hand side. That means, what is means right-hand side? That means a little bit bigger than 2. So which one is a little bit bigger? It's this one here, right? So that means x getting to 2, getting closer and closer to 2, but always a little bit bigger. So it's a 2 to the square plus what is here? Whoa, now I see, my left-hand side limit equal to right-hand side limit. Good, right? So that means what happens here? My limit of getting to 2 is what? Is exist, right? Exist to what? Is exist to 7th here, right? So but the f of x equal to 2 is equal to a, but that's fine. My limit just tell me I'm getting closer and closer, to the 7th here, right? So that's what is the limit mean. Okay, so in here, okay, so let's see here the infinity limits. What is the infinity limits? That's the limit, the going to the infinity, and so still we say the limit is not exist because it's not a fixed numbers here, right? So let's just take a look at the notations here. What is the infinity limit? That means I'm going to limit x approach to a, f of x is equal to infinity. Okay, and now we said here, sometime you approach to infinity or approach to negative infinities here. Okay, so now what is the vertical asymptotes here? Okay, so the vertical asymptote, okay, so vertical asymptote of y is equal to the f of x, right? It's a vertical line at x equal to some value a, and for which at least one of this limit hold. Okay, what's that mean? Okay, so let me show you a graph here. Okay, so for examples here, so this is my first one here, second one, third one, fourth one here. Okay, so this is my asymptote, this is my asymptote, this is my asymptote, this is my asymptotes, right? So this is A. It's all at the point A. And this is the line x equal to a, x equal to a, x equal to a, x equal to a. So this is my asymptote. That means my function go like this. That means my function either go like this way, or my function can approach to the negative infinity and go approach from the right hand side to the infinity, or from the right hand side to the negative infinity. That's why they say as long as one of this one exists just here, then you will have the vertical asymptotes, right? That means the function going to get closer and closer to this line. So this is the line we call the asymptotes, right? So this is what we call this the asymptote. Okay, so that means your function going to get into the infinities here. Okay, so now let's take a look the problems in here. Okay, so now in here, all right, so I want to evaluate. Okay, so the first things here, let's take a look at number 6 here. Evaluate limit x approach to 1. Okay, so remember, we always, now since we know the right-hand limit, left-hand limit, right? So I said limit x approach to 1 from the right-hand side. What's that mean here, right? So be careful. That means the right-hand side of the 1. What means the right-hand side of the 1? That means always a little bit bigger, right? So if this is a little bit bigger, then what happens here? That means 1 minus x will be smaller, or, the greater than 0. So we'll be getting closer and closer to what? A little bit smaller than 0, right? So that means in here, I'm going to approach to what? The negative infinity. All right. And then the same things here. Now in here, if I say the x approach to 1 from the left-hand side here. So remember, what is this one's means here? That means it's always a little bit bigger, a little bit smaller. So it's 1 minus something a little bit smaller. So what I'm having here, I have something always a little bit bigger than 0. If it is a little bit bigger than 0, what is the value going to approach to? So approach to the infinities here. So I know this is left-hand side limit, this is right-hand side limit. They are not equal. So this is limit what? do not exist, right? So they one end approach to positive infinity and one end approach to negative infinity. So if you do your graph, it probably goes something like from the like in here. So probably there will be some graph like this, right? And then you close to the left hand side, go like this, right? So that's why this is still is your vertical asymptotes here. All right, so now let's take a look at this graph here. All right, so now let's take a look here. All right, so let's say first, limit x approach to 2, -2 from which side? Right-hand side. -2 is here. Oh, from the right-hand side, I'm approaching to from here, right? So what is my limit approaching to? Infinity. -2 from the left-hand side, that means I'm approaching to from here. So that means my function value approaching to here. What is it equal to? Equal to infinity. So now the left-hand limit equal to right-hand limit. So I know x approach to -2 will be what? To the infinity. Good. All right. So now let's take a look at the 3. All right. So x approach to 3 from the left-hand side. That means I'm approaching to 3 from here. That means your graph going to go here. So what is the value? Is infinity. Okay, so then the next one here is the x approach to 3 from the right-hand side, right? Because this is positive right-hand, that means I'm approaching from this graph. So what is this one here? Is zeros here, right? Because this graph going to 0, close to 0. So what is in here? We say is do not what? Do not exist. All right. Okay, so now let's take a look at the other ones here. Okay, so these ones here, so limit x approach to 0 from the right-hand side. That means from this end. So that means my function value go here. So what is my limit? Positive infinity. And then my limit approach to 0 from the left-hand side. So what is the limit of values here? Go down here, right? So I'm going to the negative infinity. So what is these ones here? This ones here is do not exist here. All right. Okay, so this is the part 1 of our lecture number 2 for this unit. Like I mentioned in the beginning, at the beginning, I like to divide this lecture into 2 parts here because it's kind of like a long lectures here. All right, so let's break here, and I will, I will talk to you in the next videos here. Okay, bye. Have a good day. All right.